Hello friends, welcome to another video in my YouTube channel Automation Testing Online. Without wasting time, we will begin the session. To test an software or application, we needed to follow some principles to make the product defect free. Here in today's session, we are going to discuss the 7 essential principles of software testing. The first principle is testing shows the presence of defects. We perform testing on a software or application to make sure that it is defect or bug free. While performing the testing, we can identify only whether the software or application has any errors. The primary purpose of software testing is to identify the number of unknown bugs using various methods and test techniques. Does that mean that testing allows us to find all possible defects? No. Even if no defects are found, it is not a proof of correctness. We cannot prove the absence of defects. No matter how many tests we perform, we cannot assure that the product is 100% defect free. The areas which we explored can be defect free, but the areas which were unexplored may have some defects. So, does it mean that we have to deliver the product to the customer with defects? Absolutely no. Here we have to test the major and critical modules of the application and make it defect free. We have to ensure that the product is safe and reliable in the market. Meanwhile, we have to figure out other issues, which is why we receive many updates while we are using the product. These updates are the defects which were fixed later. We have to ensure that the product has no major or critical functionality defect. The second principle says that exhaustive testing is impossible. Sometimes it seems very hard to test every modules and features with effective and non-effective combination of input data throughout the actual testing process. Exhaustive testing is impractical to be conducted. That is, there is no limit for creating test cases. For example, let's say that a requirement says that it accepts decimal numbers. At first, we are giving numbers like 9.5, 2.2, 101.2 and so on. Do you think that we can test all the decimal numbers? No, it is not possible to test all the decimal numbers, and decimal numbers doesn't have a limit. If we try to test, it is a total waste of time. When the test case preparation doesn't stop, then how will we guarantee the execution of the test cases? So, we have to test according to the importance of the modules. Now, here a question arises. How do we ensure that the test cases and test scenarios we prepare is efficient enough to release the product? Which is why we have to use the test case design techniques. Test case design techniques helps us to minimize the test cases and identify the possible defects. It is also time saving. Third principle is early testing. Early testing means all the testing activities should start at the early stage of software development lifecycle. We should not start testing after the development team has given the build. We should start the testing as soon as the requirement is received from the customer. The advantages of early testing is early testing helps us to find the bugs at the early stage. Fixing those defects costs us very less as compared to those which are identified in the future phase of the testing process. Fourth principle is defect clustering. Defect clustering says that when defects are found, those defects will not be uniformly distributed among all the modules. We will understand more by looking into an example. Let's say that we have a requirement that has 9 modules which are A, B, C, D, E, F, G, H and I. Here module A has 5 defects, module B has 10 defects, module C has 13 defects and so on. As soon as we find the defect in module A, which is 5, we cannot assure that all the modules will have the same number of defects. Each module will have different number of defects. Defect clustering also says that majority of the defects come from the smaller number of modules. As we can see here, module B has 10 defects, module C has 13 defects, module F has 15 defects. As the principle says, the majority of the defects come from the smaller number of modules, which is 3 modules. We have 3 modules which has the defects, and these 3 modules has the higher number of the defects. Sometimes testers may have a misconception that if no defects are found in the larger modules, there is no possibility for defects in the smaller modules, which is absolutely wrong. We should not ignore any module irrespective to its size or complexity. We should give independent approach when it comes to each module. Fifth principle is pesticide paradox. This principle states that when we execute the same test cases again and again over a particular time, then these test cases will not be able to find any new bugs in a software or application. For example, if you are testing a set of test cases and when we are not able to find any bugs, then we are testing the same set of test cases again and again. As I said, it does not mean that repeating testing on the same set of test cases will allow them to find new defects. In order to overcome this, we have to keep on updating the test cases. At least after 2 or 3 releases, we have to update the test cases to find more defects. Sixth principle is testing is context dependent. This principle defines that we have multiple fields such as e-commerce website, commercial websites, and so on are available in the market. All these websites cannot be tested in the same way because every application has its own features, needs, and functionalities. So, 2 different products cannot be tested in the same approach. The test techniques, test methods, everything remains same. Only the approach of testing differs. For example, if we are testing an health insurance application, this application will not be tested in the same way we are testing an e-commerce website because these 2 websites has different level of criticality and complexity. Therefore, testing depends on the context of the application. Last principle is absence of error fallacy. Once the application is completely tested and there is no bugs before the release, then we can say that the application is 99% bug free. Absence of error fallacy means identifying and fixing the bug will not help if the application does not meet the customer's requirements. No matter how many defects we find and fix, if the application does not fulfill the customer's expectation, then all of this testing is of no use. So friends, that's all for today. We have discussed all the 7 principles of software testing. In my next video, we will meet up with another topic. Thank you.